everyone. Welcome to our session on a deep dive into macOS MDM. My name is Jesse Endall.
I'm Max Bélanger.
I work at a company called Fleetsmith. We're an Apple device management product.
And I'm a staff engineer at Dropbox.
A little bit of background on why we did this research. It's what our product does. So we have kind of a vested interest there. It handles, OS updates, app updates, security policy enforcement, and compliance for Apple devices. We have a really high security bar for our products, so we want to make sure it's secure by design. And we've put a lot of work into making sure that's true. Our goal with this talk partially was to increase the security of MDM and DEP, and also kind of raise the bar for all MDM vendors.
And I just wanted to work with Jesse again.
So, quick agenda. We'll be covering some basics, some terminology, some concepts, moving into an overview, followed by the deep dive section, which Max will walk us through. Also disclosing the vulnerability that we found, and explaining how that works. Then we'll actually be exploiting that. So we have a laptop here in the box. If all goes well, our demo will work with no issues. And finally, we'll go through the fix and some conclusions and takeaways. So let's jump in. What is MDM? It can be a confusing term because it can refer to an entire kind of product category. When we say MDM, we mean Apple's specific flavor of MDM, which is protocol, as well as a few other things that we'll touch on to set system configuration in a centralized way through an MDM server. And that MDM server is built by a third party. It's not something that's run by Apple. So that could be Fleetsmith, that could be another product like AirWatch. So if you've heard of kind of mobile device management products, that's what we're referring to here. And an MDM server can send MDM commands to a device. That includes things like a remote wipe command in case the device is lost or stolen, as well as a command to install a configuration profile, which could contain something like password complexity requirements for your enterprise, or perhaps Wi-Fi network settings to join the WPA2 network and include the network password, for example. All right, DEP. This stands for Device Enrollment Program. This is a complementary technology to MDM, and it allows you to have devices automatically enroll with an MDM server immediately upon first boot, the first time they connect to the network. This is most useful, obviously, when the device is brand new, because it can help you achieve the holy grail of IT workflows, which is a zero-touch deployment workflow, meaning the IT team never has to touch it. The laptop ships directly from Apple to the employee. They're the ones to unbox it, connect to Wi-Fi, and boom, it sets itself up automatically through your MDM product. Obviously, this could also be useful for reprovisioning workflows. If you have a device that's being used by an employee, they leave and you want to wipe it and redeploy it, it could also be useful in that scenario as well. SCEP. This stands for Simple Certificate Enrollment Protocol, and this is a way for a device to send a certificate signing request. This is a request for a certificate to a SCEP server. Generally, this is going to be implemented as part of the MDM product. The client will, send its request. The server will evaluate whether or not it should grant the certificate, and if the answer is yes, the device will receive a TLS client certificate that's used to authenticate later on to the MDM server. Configuration profiles. I touched on this briefly already. This is Apple's standardized format for enforcing system configuration, such as password complexity requirements, Wi-Fi settings, disk encryption, you name it. It's a file format that can contain multiple payloads. So you can have one file that contains the settings for all three of those things. And it's based on the plist or property list format, which is an Apple-specific flavor of XML. The payloads within the configuration profile can also optionally be signed and encrypted to validate origin, ensure integrity, and protect their contents. So a quick overview of the entities at play here. There's really 5 key players. There's Apple themselves running some of the server infrastructure and, of course, the manufacturer of the devices. Next up, you've got resellers. This would include large resellers like CDW. It would also, in the world of DEP, include Apple Retail. Third, you've got the MDM vendor. Fourth, you have the customer. This is the company that's actually trying to manage their devices for their enterprise. And fifth, you of course have the device itself. Okay, protocols. The MDM protocol is really a combination of two protocols. The first is Apple Push Notification Service, APNS. You might have heard this in relation to other technologies such as iMessage, if you've sent iMessages on your iPhone. That's actually built partially on top of APNS. Next up, it's also a RESTful API. So there's sort of two pieces to this here. And that's the part that the MDM server implements. And that's a RESTful API. Communication occurs between the device and the MDM server. And the device receives commands in plist encoded dictionaries. This is all over HTTPS. And optionally, MDM servers can be pinned, but it's not a requirement. Authentication works differently for each of these. So as I mentioned earlier, that client certificate issued via SCEP is used for authenticating to the MDM server. For the push notifications, that's actually done via a push notification token. We won't be going in depth on APNS today because there's already been a lot of research on that whole area. So that's why we won't be diving into that today. All right, DEP. There's actually 3 separate APIs related to DEP. One for resellers, one for MDM vendors, and one for the device itself to prove its device identity, which is undocumented. The nice thing about all these is they're more modern APIs. They use JSON, no plists. And today we're only going to be focusing on that middle one there, the MDM to Apple communication. Between the MDM vendor product and the DEP Cloud Service API. Okay, the Cloud Service API, what is this thing used for? It's another RESTful API. There's 2 main use cases. One is to sync device records. So when a reseller or Apple themselves adds a new device into their internal DEP database somewhere, then those device records need to be synced over, pulled into the MDM product somehow. That is done over this DEP Cloud Service API. And then the other thing that happens is the MDM vendor pushes back what's called a DEP profile, which contains a few different things. And that DEP profile is delivered to the device later on, the first time it boots up. So that DEP profile, which is a JSON payload, contains 3 things: the MDM server URL, any additional certificates that need to be trusted for the sake of pinning, as well as any setup assistant configuration you want to do. So that setup assistant you see when the Mac first boots up, you can customize which screens are shown there. And this authentication is handled with OAuth between the MDM server and Apple. So SCEP is another RESTful API. It was created at a time when TLS and HTTPS weren't that widespread, and so it relies on CMS or PKCS number 7 signed data to ensure message integrity. It supports the concept of a challenge password for authentication. Unfortunately, in the RFC, that's really just defined as like a string. We think that field should be used a little bit more carefully. And so what we do is we actually stick an HMAC in there that's server generated so that we can correlate that with a specific enrollment request from a specific user. All right, establishment of trust between all these things. It's pretty complex and we're not going to go into it in detail here, but we do cover this very extensively in great detail in the white paper. So definitely check that out. And it's just important to call out that there's a lot of cross-signing that goes on, a lot of uploading and downloading of certs in order to get to the point where the MDM vendor now has the right to send MDM push notifications down to the device, as well as sync those device records to the DEP servers with Apple and push those DEP profiles back. All right, some differences here. The authentication for MDM is via APNS, whereas for DEP, it's that OAuth token. So different auth stories here. All right, putting it all together. So there's sort of, if you look at the entire life cycle, the entire bootstrap process for DEP and MDM, this is what it looks like from start to finish. This is kind of hard to get an understanding of, so we made a visual for this. As you can see, the first step is the reseller or Apple creating that device record. The next thing that happens is the customer the enterprise, actually goes into something called Apple Business Manager, which is a web portal, and assigns that device to a specific MDM server. From there, the MDM server is able to sync those device records over, as I mentioned earlier, as well as push those DEP profiles back to Apple. Next, the device actually checks in via DEP to Apple, receives this profile. Then we've got the sort of bootstrapping of the initial MDM config, which Max will walk through in greater detail. And finally, the device can start receiving MDM commands like that remote wipe command, install a configuration profile, etc.
All right, thanks, Jesse. So today's deep dive will focus on the 4 later stages of the process. Now, for more info on stages 1 through 3, I do recommend you check out the white paper. So as we've seen, the later steps involve the device itself. In these steps, macOS interacts directly with Apple and the MDM vendor servers. We're going to use a scenario here to sort of walk through the deep dive. So imagine a user is getting a brand new MacBook and isn't unboxed it. That MacBook has been previously configured by the employer to set itself up automatically via DEP and MDM. So DEP and MDM enrollment on the Mac involves many different agents. Daemons, it's a bit of a confusing maelstrom of dynamic linking and IPC. However, there is very conveniently a single framework that abstracts away all that complexity for us. That is the private configuration profiles framework. This gives you a set of functions that map really well to the steps that we're going to go over today. So if you've ever seen this screen, then you've seen what is called the setup assistant, or internally named MacBuddy. This is actually a Cocoa application. This is the first thing you see when you turn on the device. So that is its icon, complete with bow tie. The macOS setup assistant is one of the users of this framework, and that's how it enables DEP and MDM enrollment. So to simplify our overview today, we're going to take the point of view of the Mac setup assistant, and we're going to use that framework as a lens to look at each step. So let's recap. So we have 4 steps to go over. The first one is the DEP check-in. Now, the purpose of this step is to verify whether the device is DEP enabled. And if so, we have to sort of take special action. So in this step, internally this is called retrieving the activation record. Now, Jesse detailed what a DEP profile is. That is roughly the internal name for a DEP profile. It contains almost all of the same information. This is implemented by a daemon underlying the configuration profiles framework. And a bit of a quick note on this. This is a pretty common macOS pattern. In order to guarantee privilege and process separation, Apple will typically farm out work to daemons under the hood that have specific entitlements allowing them to do the work. And so the configuration profiles framework itself doesn't really do anything here. It just signals an underlying daemon to do some extra work. Now, this step will begin as soon as the device is connected to WAN. So the second it has a network reachable or internet reachable IP, it will begin to attempt checking in. This is driven by the private CP fetch activation record function. And as I said, it's implemented by a daemon called Cloud Configuration D. Now, this is a launch daemon, which is macOS lingo for it runs as root and can be kept constantly running. And it is signaled through macOS specific IPC called XPC, which if you've done any kind of iOS development or Mac development before, you are either directly or indirectly aware of. So let's go back to our fancy architecture diagram. So we have setup assistant, which is now linked the framework, and it is ready to call the function to retrieve the activation record. So at this point, it sends a message to Cloud Configuration D over XPC to say, well, you should actually implement the fetching process. And now we'll go over exactly what happens during that process. So at this point, before we can make the request to Apple to actually retrieve our DEP profile, we need to establish a rather peculiar type of encryption, which is internally called absinthe. There's the object in Cloud Configuration D that runs this is internally called MC Tesla Configuration Fetcher, which is partly pretty well named. So this manages a 5-step process. The first step is to plainly retrieve a certificate from Apple's servers. Now, one quick note on this. Absinthe is a rather complex topic, and we're not going to go into too much detail, but we'll go over the sort of basic steps here. So first, it retrieves a certificate. Next, it uses that certificate to initialize the internal state of Absinthe. This is through a function called NAC init. This, interestingly, also uses various device-specific pieces of data, things like the serial number, which it retrieves via IOKit, but also MAC address and others. Now, with that data, once the initialization is complete, it posts that raw data back to Apple via the session endpoint. We're not exactly sure what this does, but it appears that an extra handshake is necessary to ensure the device is who it says it is. And finally, with the result of that, it calls NAC key establishment, which completes the initialization for the encryption. Now, what we believe is that Absinthe's job is to provide a way to encode on a per-device basis, and so to relatively securely identify a device for Apple. And finally, now that the encryption is ready, we're ready to make the request. The last step is to make a post, including a JSON payload to the Mac profile endpoint. What this will do is take the example JSON payload below. It will encrypt it using Absinthe, base64 it, sign it, and send it over HTTPS. So let's go back to our architecture diagram again. As you can see, Cloud Configuration D is interacting with Apple at this step, and it's using both TLS with the standard root certificates installed on the device, along with the extra layer of Absinthe encryption. And at this point, it basically says, I am this device, I am this serial number, what is my activation record? What is my DEP profile? Should I be enabling DEP? Now, in response, the server provides a JSON dictionary that is essentially a slightly differently formatted version of the DEP profile. And this includes what Jesse mentioned, things like customizing the setup assistant. But most importantly, this includes two fields that will unlock the next step. The first one is the URL of the MDM vendor's activation profile endpoint. We'll go into exactly what that means, but that's the main thing that will enable the next step to occur. But most importantly, it also returns the DEP profile's anchor certs property, meaning for that URL that is referring to an MDM vendor endpoint, you can also provide DER encoded certificates to pin that next request. And so far, we're able to validate server trust, and we'll be able to continue to do so. So going back to the overall process, we now know that we are a DEP device or not. Now what's next? This step is called profile retrieval. In this step, we'll be retrieving the configuration profile from the MDM vendor directly. So we're done talking to Apple for now. So if you've ever seen this screen, this is actually the screen that indicates that your DEP profile has enrolled you into DEP. Once the activation record is downloaded, this will appear. It is possible to allow users to skip this in case they don't want enrollment, but it's also possible to make it mandatory. So in this case, you can see that there's no skip button. So in this step, we need to retrieve the activation profile. Now, what is an activation profile? That is the internal name for a DEP-delivered configuration profile. So Jesse detailed config profiles earlier. Those are a rather versatile plist-based files that contain multiple payloads that can be installed on a device. Now, for MDM purposes, this is a little bit more restricted, but and we'll go into that in a sec. This step will begin immediately as soon as the user clicks next. It's driven by another function in configurationprofiles.framework called CP get activation profile, unsurprisingly. However, this one is not implemented by Cloud Configuration D. This time, it's implemented by a somewhat older component of the OS called manageclient.app. Fun fact, this is actually part of the older MCX infrastructure that predates much of today's modern MDM. What's also interesting is it doesn't use XPC this time. It uses MIG, which is a much older IPC mechanism on macOS. This is also a launch daemon running as root, though it can delegate to per-user tasks in some scenarios. However, in this case, there is no user on the device yet, and so almost all of the work happening in the daemons will be happening as root. The implementation here, in case you want to go sleuthing, is the following. So what exactly happens in this step? So we send a request to the URL that was provided earlier. That URL is pointing to an MDM vendor server somewhere, and its job is to return a configuration profile. And again, if the anchor certificates were provided, the implementation will actually pin using those certs, and we validated that that is the case. Now, a request is a very simple property list containing up to 7 keys. providing device identification. So while the device is identified with Apple already, it now has to prove who it is to the MDM vendor. And in this case, it will provide a serial number, but also a UDID, OS version, product name, that kind of information. Now, that request payload is interestingly CMS signed and DER encoded. It is signed using the device's identity certificate that's part of Apple Push Service. Interestingly, it also includes supplementary certificates in order for, we believe, to validate them. But that certificate chain includes a now expired Apple iPhone device CA. It is unclear why that is still the case. It is likely a very good story. So let's go back to the architecture. At this point, Managed Client is ready to talk to MDM, and it says, well, this is who I am. And what is my configuration profile, which the MDM vendor can now provide in response. Now, in this case, TLS is used, and the anchor certs will be used to pin. So we consider this step as being secure. All right, so we're on to step 6. We have the configuration profile. We know we're in DEP. What do we do next? Well, config profiles now have to be installed. Now, as a quick reminder, a configuration profile can be installed in many ways on Mac. You can get it automatically through DEP. You can actually download it and double-clicking on your desktop, which is how some small startups, IT departments might operate. You can also retrieve it. You can also receive one through MDM itself, which leads to some fun recursiveness later. But now that we have a profile, we have to install it. Now, once it's retrieved, the profile is stored on the system. The location is not super relevant, but what is interesting is that it is system integrity protected. What that means, in case you're unfamiliar, SIP is a mechanism introduced in macOS Sierra, I believe, which allows the protection of system folders. And so no one, including root processes, can write to those folders. So technically, the profile is secure. Now, this step will begin automatically as soon as the profile is retrieved if you're in Setup Assistant. Now, again, this also maps to a function in configuration profiles.framework, which again is aptly named cp install activation profile. Interestingly, this is implemented by yet another daemon called MDM client, which again is relatively recent. So this one's using XPC. Now, it can run either as a launch daemon, so meaning as root, or as a launch agent, meaning as a user, depending on the context. In our context, so in our scenario, it will be running as root. So a quick refresher on configuration profiles. They are these large XML documents. They can contain multiple payloads. And the installation of a profile essentially amounts to looping over the payloads and installing each one at a time. Now, the framework to do so has a plugin-based architecture. Each payload type is associated with a plugin. And so, for example, the certificate payloads, so if you are using the configuration profile to deliver a certificate, will be implemented or will be installed by a certificate XPC service. Now, XPC services are the modern way to achieve privilege separation on macOS. Interestingly, plugins can either be in the main framework or in the older managed client application. And so that can make things relatively confusing when you're looking for traces. So typically, an activation profile, so a DEP delivered config profile, will include, if provided by an MDM vendor, 3 payloads. Now, the top one is expected, COM Apple MDM, and this contains the settings necessary to enroll the device in mobile device management with the MDM vendor. But you can also include other payloads, such as SCEP, to securely provide a client certificate to the device, or PM, in the case where you would want to install a trusted CA certificate to the system's keychain. So if you've ever read Apple's public documentation on the MDM protocol, installation of an MDM payload is actually equivalent to what Apple calls the MDM check-in protocol. Now, what that essentially does is sets up the device for receiving commands from an MDM vendor. The payload in an MDM the MDM payload in the configuration profile will typically include 3 important properties. First, there's going to be the check-in URL. That will be used in the immediate, and as well as a command polling URL, which will be used later on. That also includes the APNS topic that you can use to tell the device via push notification to poll the command polling URL. So to install the MDM payload, in the immediate, a request is only sent to the check-in URL. This is, again, implemented in MDM client. What's important to remember here is MDM payloads can actually depend on other payloads. So you might be asking yourself now, how do I pin? I've just introduced two new URLs that are MDM vendors. They're third-party URLs that are not Apple signed. So how do I actually pin those? Well, the answer is fascinating. The MDM payload is allowed to depend on other payloads in the configuration profile. So, for example, both the check-in and server URLs have matching properties allowing you to refer to another payload by its unique identifier. And that essentially says the certificate in that payload you should pin using, basically. The other important thing that the payload has to include is an identity certificate. Each device has to have a certificate that uniquely identifies it. This is mandatory. This is another property in the MDM payload, and it's meant to refer to another certificate. Typically, SCEP will be used, though I don't believe that's the only way to achieve this. It is probably the best way to achieve this. I guess one last thing on this. What's important here is that you're essentially pinning by ID. You're not pinging by using a DR encoded list of anchors, which is a little bit easier to do. So, going back to our architecture diagram, the setup assistant requests through configuration profiles that the profile be installed. And so MDM client receives that. Fun fact here, it actually loops back to itself because of the recursive nature of profiles, but we're not including that in the diagram because that blew my mind and it was not enjoyable. So the request that's made here goes to the check-in URL on the MDM vendor's servers, but again, it is TLS, but it is pinned with a certificate if you provided that ID. And so you have a way of making this secure. And so now we get to the last step. At this stage, the MDM server is ready to send provision devices commands. So after the check-in is complete, that means that the push notification topic is ready and the device is ready to receive notifications. Once a notification is received, MDM client, again, that same process, will be handling the push and will, in response, pull the MDM server using the server URL property of the payload that was passed in. Now, this, of course, makes use of the other properties in the payload as well. And so you are going to be able to pin that request using the matching pinning certificate UUID's property. And then the identity certificate property I mentioned earlier will be used here as the TLS client certificate once the polling request is made. So a little bit more visually, the process is now asynchronous. So we start bottom left with the MDM vendor who decides to issue a command to a device. It uses APNS to send the push to the device. MDM client receives it, responds to it, but not directly through the push service by definition. It does that by contacting the command endpoint on the MDM vendor's servers. And again, you can see that it is using TLS, and you are able to pin using the certificate IDs. And so far so good, right? And now we get to the fun part. MDM supports a very wide range of commands. And one of the most popular commands is install application. This is pretty self-explanatory. It allows remote silent installation of applications on the device. What's interesting here is that's implemented not in the MDM infrastructure on the device, but it's implemented in using the App Store's APIs. So the command request contains the URL to a manifest. The manifest's job is basically to describe the app package. It says this is the app's identity, this is its certificates potentially, and this is where you can retrieve it. The manifest is going to be encoded as a property list, as many Apple payloads are. But importantly, it includes the URL of the package to retrieve and install. Now on macOS, that has to point to a signed distribution package, which will be a .pkg. Now the way this is implemented, and we're going to go really deep here, MDM client will use the Commerce Core framework. This is part of Commerce Kit, which is the private APIs built around the App Store on macOS for other OS services. This framework contains various services. Each are backed by a specific launch agent or daemon, depending on the context, again. Store Asset D's job is to download and process manifests. And if they're valid, it will leverage stored download D to download and install them. Now, what happens when MDM wants to install a manifest is it uses a private function called ckmdm process manifest at URL. So let's look exactly at how this works. MDM client, while executing the install application command, will link against commercecore.framework, which will itself use XPC to trigger the asset daemon to process the manifest and validate that it is correct. I skipped a step there. It will actually first download the manifest from the MDM vendor's endpoint and then process it for validity. Now, what's interesting here is there is no pinning, and we'll get to exactly what that means. And again, once the manifest is validated, it will download the package itself and install it. What's interesting is the MDM and the store, they're two very separate components of the OS. It's safe to say they have different threat models. The MDM client here is not evaluating the trust of the manifest URL, and neither is the store. In fact, Store Foundation, which contains the core classes that power Commerce Core, do not evaluate trust at all. This allows a man-in-the-middle attack. So as an example, in this case, a state actor or someone with considerable resources could target a specific organization by man-in-the-middling commands from the MDM vendor. Now, this is not limited to the DEP scenario we've looked at. This could actually happen during later commands if the MDM can be established.
They can't man in the middle of the commands, but they can man in the middle of the
That's right.
fetching of the manifest.
That's right. Sorry. You can man in the middle, not commands, but the actual install application command. And with that, we'll go to our demo. And while we get set up, I'll go over the details of this. So we're going to simulate a malicious ISP or a state actor by using macOS's internet sharing, as finicky as it is. We're going to be proxying all the traffic from a brand new device using man-in-the-middle proxy. We're going to simulate a compromised CA by using a valid cert that we created from Fleetsmith CA. And we're going to intercept the request for the manifest as the device first boots. And rather than provide the Fleetsmith's agent, we're going to be serving a malicious manifest that will download a mysterious other application and install its package. Now, what's important to say here is that developer ID certificate requirements still apply. And so packages still have to be signed. And so there is the extra step that an attacker would have to take of actually signing their malicious application. Though this is still relatively easy to do. It is important to note, though, that Apple is making great strides here with things like notarized developer ID certificates. They are adding quite a bit of checks to make sure that malicious software is harder to create. But this is still strictly possible.
And the last thing I'll add there is the developer certificate that's used to sign that distribution package does not have to be any type of cert that's associated with a business entity. It can be a personal Apple developer certificate. And so for the sake of this demo, that's exactly what we've done here.
All right, with that, was pink. Right, so the device is first booting. Let's see if once the graphics adapter gets ready, I think we'll be able to see what's going on.
Yeah, it's worth calling out that the only way that this is possible is by really simulating that nation-state level attack by both being able to man in the middle the internet traffic from the device, so maybe having the ability to see internet traffic at the ISP level, as well as having the ability to get a certificate issued improperly from a commercial CA. Both of these things have happened, sometimes in the same country. Sometimes in countries that are not friendly to, journalists, for example. So it is a real-world kind of situation here that we're simulating. But it's worth calling out that the only reason we can do it is because the device at this point in the bootstrapping process already trusts the Fleetsmith CA because it's delivered in that initial configuration profile. So this can't be done without a lot of resources, basically. So let's make sure we have some network connectivity before proceeding here, since that is pretty important. So for some reason, this one's not working. But let's test with this one, which we just freshly wiped. So it should work just fine.
Demo gods and networking.
Yep. Okay, this one has network.
This one's ready. Okay.
So let's go ahead and proceed. There we go. There's the remote management screen. So this means that the device has received its DEP profile, that JSON payload.
So at this point, it will retrieve the configuration profile and install it.
And we are actively man-in-the-middling, which you cannot see, unfortunately.
All right.
All right. Let's proceed.
And so at this point, we can tell that
looks like it worked, yeah.
It looks like the payload was installed, the agent was downloaded, or what it believes is the agent was downloaded. And this is usually the part where a progress bar would be nice. But
yeah, it usually takes around 30 seconds at this point.
Yeah.
And there we go.
And the agent has been replaced with the calculator. And so what is supposed to be Fleetsmith's agent software is now, so our package, our malicious application in this case, created a launch agent, or a system level launch agent that cannot be stopped, that runs the calculator constantly. And so I don't believe you can close this. I don't know if we fixed that, but
I think we removed that.
Oh, maybe we fixed it. Yeah.
Testing, yeah.
It was pretty annoying when testing.
Yeah, so we installed this to the system-wide launch agents folder, which means any user that logs in will have the calculator started. It's important to note, though, that even though we launched this in a user context, at the time that our malicious package is installed, we do have the ability to execute any command as root. And so this demonstrates that the device is actually fully rooted at first boot.
All right, let's go back to the slides. Thank you. Well, the good news is there is a mitigation already in existence for this problem. A new command was introduced recently called install enterprise application. This includes new properties that allow you to control the trust of that URL for the manifest. And so this is available in macOS 10.13.6, thus also 10.14. What's also important to note here is that there's a time delay for new hardware to support the fix, as we've just demonstrated. What's also important here is that this requires the MDM vendor to do its part. The new command has to be adopted before the mitigation is fully ready. Now, how does this actually work? There's now an extra property, manifest URL pinning certs. This is, again, a list of DR encoded anchor trusts that will be used when evaluating the trust of the manifest URL. This can ensure, you can also ensure that revocation checks are performed, which is quite nice. Under the hood, what happens? Well, the CKMDM process manifest at URL function, which used to only take a URL as a parameter, and another thing that was more of a flag, now actually takes in a dictionary. That dictionary contains private keys that map to the properties in the new command. And also, most importantly, Store Foundation's core objects now have the ability to evaluate trust, which was a relief to see. They actually, if you're curious, this actually uses NSRL connections, standard delegate methods for authentication challenges. So let's move on to some takeaways here. Number one, this is a really complex system on macOS with a lot of moving parts. Some will have different threat models, and what that means is vulnerabilities or bugs can appear at the intersections or at the borders between those. Jesse?
Yeah, so in addition to these takeaways here, we, through our research, came up with a bunch of recommendations for Apple here on kind of how to improve the whole security story for MDM and DEP. And so here is that list of recommendations. The first is that we'd really love to see the entire security model for DEP and MDM documented. If anyone's read the incredible iOS security guide white paper that they've published, that's really what kind of along the same lines of what we're thinking here. So we know they have the ability to produce something of a really high caliber, and we'd love to see the same thing, including a description of what the role of that Apple iPhone device CA is. The next is that we'd really like them to be more aggressive in a technical enforcement in the OS that requires pinning for all of these things. Right now, all of this is really optional and up to the MDM vendor, which, given how early in the process it is, and the kind of really scary implications, if an attacker was to really package up this exploit and use it at scale, we really think that it would be a great improvement if this was required. The next is that we really think any configuration profile that contains sensitive data, so that could be like a TLS private key, for example, or it could be the Wi-Fi payload that includes the plaintext password for your corporate Wi-Fi network, right? Any payload that includes sensitive data like that, we think the OS should enforce that it's both signed and encrypted. This is also optional, but it's really not very heavily utilized in the wild by various products. Fleetsmith does do both of these things, but we'd really like to see this required as well. And you might be thinking, well, isn't this already TLS protected? And the answer is yes, but if you look at the past few years, you've had Heartbleed, you've had Poodle, you've had Apple's own GoToFailBug, and so given the history of TLS phones, we really think that this is a great defense in-depth measure to require that these sensitive payloads are protected. And in fact, Apple's own documentation says on page 19 of the configuration profile reference, they give this guidance that because the password string is stored in the clear in the profile, it's recommended that it be encrypted for the device. And you can get really powerful here and encrypt these payloads on a per-device basis because the SCEP server can safely escrow the public key, which is part of the certificate, right? Even though it doesn't have the private key, it can use that public key to encrypt these payloads. And so that's something that should be relatively straightforward for people to implement. The last one is that we'd really like to see that DEP Cloud Service API contain just a bit more information. It already contains information on like the model, the OS family, so it'll tell you if the device has macOS or iOS, for example. But we'd like to see 2 additional fields in that API, one with the OS version and one with the OS build number. And the reason we want that is so that we can surface that information in product, so that if there is a vuln on a version of macOS that's shipped from the factory, at least you have the information at your corporation, from your IT team, your security team, at least has the information to know maybe we shouldn't rely on on that OS version if we're shipping it to a country that's might be doing some of these things that we've talked about, right? All right, and then for MDM vendors, we wanted to share what we think of as sort of like a security checklist to make sure that you're doing all the right things. And we tried to make it kind of really concise and targeted on just the highest impact things. So pinning at every step of the process, super important. The anchor certs in the DEP profile, so that the first time the device calls in to the MDM server, that's pinned. That's step 4. Step 5, which is pinning the actual MDM URLs for ongoing polling for new commands, both for the check-in URL and the commands URL. And then finally, in step 7, pinning using the new install enterprise application command. So right now that is also optional. Install application is not deprecated, it's still available. Apple has given strong guidance at WWDC when they announced the install enterprise application command that they'd love to see vendors move to this, but they didn't give a hard timeline, and it is still optional as well. And then finally, this is the one that I think is the most subtle. A lot of vendors sort of supplement the functionality of MDM with an agent binary that they've written themselves. We do the same. It's really important that the vendor is pinning inside their own binary as well. So we do the same thing. We pin our root CA within our binary to make sure those communications also can't be man in the middle. And finally, SCEP is really the best option for getting these device identity certificates generated. And the reason SCEP is far superior to alternatives is because the private key is generated on the device and never leaves the device. The server never sees it. Whereas the only other alternative is the server actually generating all those client private keys and distributing them down to the client. And I think at least one vendor does this currently. All right, next is the configuration profiles. We already touched on this. We really think that they should all be signed and encrypted, especially if they contain sensitive data. And finally, this is more about the cloud production environment, or even on-prem as well, but any sensitive data that's being input into the product, like that Wi-Fi password, right, a private key, all of that should really be encrypted at rest in the database within the MDM product as well. All right, disclosure timeline. We first disclosed this to Apple on April 28th. It was acknowledged April 2nd. The new command was announced in that session at WWDC titled What's New in Managing Apple Devices on June 7th. But Apple, of course, did not share the sort of background history there. That's obviously what we're sharing today, although they did strongly urge vendors to move to the new command as soon as possible. The MDM protocol reference documentation was updated to include the install enterprise application command on July 5th, and the actual ability to use that command with devices was introduced with macOS 10.13.6, which was released on July 9th.
So this concludes our presentation, but we have a few acknowledgments we want to make before we're done.
Yeah, first and foremost, we really want to thank my co-founder, Stevie Hershu, who did a really incredible job on all of the early research for this talk. Like a straight week of 8 to 10 hours a day. The next set of people we really want to thank is Victor, Papayan, Mike, and Jesse, who have contributed just a lot to the Mac kind of security community, as well as, last but not least, Apple, of course. They've been really great, actually, throughout the whole process. And obviously, even though we found this vulnerability here, both Max and I just have a ton of respect for their security engineering team and what they're doing to improve the platform security for both iOS and macOS. And we just want to say, keep up the good work.
All right, and with that, we are done. I think we may have time for one question, but thank you so much for coming.